Okay, so let's have a look at this inequality here. Now, the first thing is the question says x is not equal to minus 3. At the very start, you can just ignore that. Okay, so when you're going through this solving it, this doesn't really come into play until the very end. The main reason why it's there is that we can't have a denominator that's 0. So at the end of the day, the denominator is something that's dividing, and we can't divide by 0 at the moment. So we can't have x equal to minus 3 because then this denominator will be 0. So other than that, this fraction looks kind of confusing, but everything else looks like something we could solve. So let's just try and get rid of the fraction. Now, when I have a fraction, so here my fraction is 2x plus 1 over x plus 3. When I have that fraction, what that is 2x plus 1 being divided by x plus 3. So how can I get rid of it? Well, to get rid of a thing that's dividing, I just multiply by that thing. So in a normal case, if this was an equality, so if there was an equals, I would just multiply across by x plus 3 and multiply the right hand side by x plus 3 too. There is a problem here though, and that is we don't know the value of x. So we don't know whether this is positive or negative. Now, why does that matter? Well, we said when there's inequalities, we treat the inequality the same as an equals and carry it down the whole time, except when we multiply or divide across by a minus, that's when we change its sign. So if we don't know if this is a plus or a minus, then we don't know if the inequality sign should stay the same or change direction, because we don't know if we're multiplying across by a plus or if we're multiplying across by a minus. Okay, so let me just explain that a little bit more. So what I have is x plus 3. Okay, if I had something like x is equal to, let's say 4, then my value of x plus 3 would be 4 plus 3, which is 7. So I would be multiplying across by a plus and not changing the sign. But if x was equal to a minus 4, then I would have minus 4 plus 3, which is minus 1. And then I would be multiplying across by a minus, and the sign should change direction. So what we talked about is how can I guarantee that I know the sign, whether it's a plus or a minus. How can I guarantee getting that to have the same sign that I can always know? So it sounds complicated when I'm putting it into words, but if I had a minus 7, okay, how can I use this minus 7? What can I do to a minus 7 to get the same answer as something I can do to a plus 7? And the answer there that we discussed is that if I square this, I will get a plus 49. And if I square this, I will get a plus 49. So to guarantee that what I'm doing here, even though I don't know what I'm multiplying across by, I can guarantee that it is positive if I multiply across by the square of that. Okay, so when I multiply across by the square of that, I'm multiplying across by x plus 3 times x plus 3, but I'm guaranteed it's a positive. Now, the denominator is not squared. So over here, this doesn't fully cancel. Okay, only the second repetition of the x plus 3 that was multiplying in, only that would cancel. Okay, we only have one x plus 3 in the denominator, so we only want to cancel one of these x plus 3s in the numerators. So I'm actually just going to cancel out that squared or turn it to like a 1 or just reduce the power by 1. So here I'm just going to be left with an x plus 3 multiplying. Okay, over here there was no x plus 3 in the denominator, so neither of those cancel with anything. So on my next line, I will be left with x plus 3 times 2x plus 1, and that is less than, so 1 times x squared plus 6x plus 9. Okay, so that's just doing out the squared from here. Okay, so I'm going to just multiply these out so that I get 2x squared plus x plus 6x plus 3 is less than x squared plus 6x plus 9. Okay, so I want all of these to be on one side of the equals. It's easier to factorize when the leading coefficient is a positive, so it makes more sense really for me to bring these over to the left hand side. Okay, so that would allow my coefficient of my x squared to stay as a plus. So to do that, I have to get rid of everything that is on the right hand side by doing the opposite of whatever it is doing on the right hand side. And I will get x squared plus x minus 6 is less than 0. Okay, now I need to factorize that the same way we have solved quadratics from now forward. So we've already looked at solving quadratic inequalities, and I solve it as if it is equal to 0 to get the roots. And then once I get the roots, I can sketch it with those roots here, and it is asked for where it is less than 0. So then I know that it is this space here. Okay, so when I go to factorize that, I am looking for factor pairs of minus 6. That adds give me plus 1, so it's going to be a minus 2 and a plus 3. So I can open up my brackets, put x as the first term in both, and then put the minus 2 and the plus 3 into the brackets. So x minus 2 is equal to 0, so x is equal to 2. And x plus 3 is equal to 0, so x is equal to minus 3. Now, what we've just said is if I draw a little sketch, so it's a happy face graph, x here will be equal to 2 and x will be equal to minus 3. Now, it doesn't want where it's less than or equal to where it's less than or equal to 0. It wants where it's just less than. So I've actually made a key mistake here, which is really follow the number line. So always put the smaller number on the left hand side. So I should have sketched that with a minus 3 here and a 2 here, because the 2 is the bigger number. And then I can see that x is anything between the minus 3 and the 2. Okay, so it looks like this. And that's it. Okay, now if it was a case where, and I'll do this in orange, this was the symbol. Okay, up here we had an equals, less than or equals. Then at the end I would want a less than or equals, except for the fact that they have said that x is not equal to minus 3. So because of that, this would not actually be here. And my final answer would be minus 3 is less than x is less than or equal to 2. Okay, but that's not the case here. It was strictly just less than. So this is my final answer.